everyone, we are the Group 1 and this is our project to our subject Intake for Renewable Energy Laboratory. And this is all about a solar setup. Let us introduce ourselves as a member of this project.
My name is MJ Grande. My name is Ian Pao Calvero. And I am Simon S. Pangilinan.
My name is Alexin Manriga. I'm Shalwin Tasterol.
I'm John Mark Carinto. I am James Lopez. And I am Richard D. Tejera.
Here are the components and parts for solar panel setup. Solar panel with a size of 60 by 25 inches and 50 watts, 50 to 20 rated voltage. Solar charge controller regulates the power coming from the solar panel to the battery to prevent overcharging and damage. Inverter converts DC power from the battery into AC power used by common appliances and devices. Battery stores electrical energy from the solar panel to power can still be used even without sunlight. DC breaker protects the DC side of the system by automatically disconnecting the circuit during overload or short circuit. AC breaker protects appliances and the AC side of the system from electrical overload and short circuit. Screws used to securely fasten and hold in components materials together. Lamp holder holds and supports the light bulb while providing electrical connection. Plug connects electrical devices to the power source safely. Extension socket provides additional outlets for connecting multiple electrical devices. Connecting wire transfer electrical current between components in the solar system. Bracket supports and secures the solar panel in its proper position. C-clamp used to firmly attach wires or components to prevent loosened connection. Then the board.
These are the tools that we will be using for our solar panel setup. Long nose plier used for gripping, bending, and cutting wires into tight spaces. Combination plier used for gripping, twisting, bending, and cutting wires or small materials. Wire stripper used for removing wire insulation and cutting wires. Phillips screwdriver used for tightening or loosening nuts and bolts. Flat head screwdriver used for tightening and loosening slotted screws. Next is Ratch wrench used for quickly tightening and loosening nuts and bolts. And these are the different sizes and types of screw nuts and bolts.
Now, let us proceed to the board where we will set up our solar panel in its components. On the upper part of the board, the solar panel diagram, lamp holder, and bulb are placed. In the middle part of the main components are installed, such as battery, DC breaker, inverter, solar charge controller, AC breaker, and the outlet. In the lower part of the board, wheels are attached to provide easy access and make the setup portable and easy to transfer from one place to another.
And now let's proceed in placing the components.
Now that we are done placing the components, let's proceed in wiring each components. Now, we are finally done in wiring each component of our solar setup.
Start or let's begin to the solar panel. We have used a solar panel here. We put the solar panel in our board, and from the solar panel, as you see in the diagram, there are two wires, the black and the red. The red is for positive and the black is for negative. And then from the solar panel, we use a DC breaker for the safety purposes of our solar panel. We have this DC circuit breaker, and then from the DC circuit breaker, as we follow, we have a charge controller. The charge controller are put in the middle of the component. Here, and then from the charge controller, we have two wires moved to the 12 volts battery. For the next wiring is two wires for our inverter to the battery. We will test the battery. Since we have two wires from the inverter, we have two wires again for the circuit breaker or AC circuit breaker. Now, let's proceed to energizing or testing the outlet if the current is good. Now, let's on the circuit breaker. And then, let's plug the main bulb. As you can see, the bulb is on. And now, let's try to put or to add some extra load. We need a charger and the cell phone. As you can see, bulb and cell phone have same outlet and same working. That's all thing.
This study focuses on the design, assembly, and testing of a small-scale solar panel setup conducted at Technological University of the Philippines, Cavite. The project aimed to determine the charging capability and operating durations of the system as an alternative source of electricity. The setup included a solar panel, battery storage, wiring connection, and basic electrical components used to store and supply electrical energy. The study is limited to a small-scale solar panel setup with a battery and inverter that have limited capacity, allowing the system to power only small electrical devices. The testing period lasted only 3 weeks, which may not be enough to evaluate the long-term performance of the system. Environmental factors such as weather conditions and sunlight intensity may have also affected the system charging and operating performance. Our project successfully demonstrated a small-scale solar panel setup as an alternative power source. The system charged the battery in about 2 hours and provided electricity for approximately 4 hours. Despite some limitations in battery capacity, inverter wattage, and weather conditions, the project proved that solar energy is a practical and eco-friendly source of renewable energy.